Okay, welcome back to my Arduino controlled stepper driven balsa wood cutter, all fully automatic. I have not finished everything on this project yet, but I still have, hopefully I'll be able to get everything done in the next week. I've made a lot of improvements in the last video. One of them is that I had gotten all my standoffs correctly in the correct height. I have not cut the slots in here for the guides. My idea is I can take standoffs that'll be a little bit taller and be able to bolt them in a slot, and you can slide this back and forth to make this track in here nicely if it's a really long stick. I have made a switch that is connected to two of my power supplies. One's a 24 volt and one's a 9 volt. So a switch, I can turn the power supply on and off. And then I have gotten that hooked up. Here's my power supply coming in. The hot power, or the hot ends, come through the positive side, I should say, come into the controller and my Darlington 128 little circuit I built, and my motor controller, which took me a little bit of time to make. I'll get into that later. What I didn't get done, like I said, is the slots. I didn't get done with my cutter. What I'm thinking on that is I'll make my fulcrum in here and have to wait until I get this put where I wanted. So the motor needs to be mounted on here, so when I make the fulcrum, I can be able to get that at the correct height to make my cutter assembly or arm to be in the correct position, so it'll cut the wood based on of where I place this razor blade. So I have a lot of math to do yet. And what I also need to make for the motor is a cam. What I mean by cam is a 1/4 inch square shaft will go through this hole, and then I'll make a small disc, and on the disc at a few centimeters out or whatever, I'll drill a hole and put a pin in there. And then truly the rest of this is necessary. I just need that pin offset from the axle, and that pin will ride in a slot in here. So let's say if that pin is vertical at 12 o'clock, it'll be right in the center of it. And then when it's at 6 o'clock, it'll be pushed down on the wood right in the center of the shaft also. When it's at 3 o'clock, it'll be at one end. When it's at 9 o'clock, it'll be at the other end of the slot. So it'll ride around and be able to lift my cutter arm up and down while it cuts the wood. So I have that yet to make. And my idea, like in the beginning of the program and the void setup, after it declares all its pins and whatnot, to zero everything out, it's going to be taking this motor and stepping it the correct distance as if you're putting this piece in here. So it'll step it through the roller and then past the cutter. So therefore when it rolls it out, just like so, it'll be able to cut it, make that the 0 mark, and start measuring out from there whenever you input a number. Well, my ideas are, let's say if you don't want to cut this wood, but you need to make a bunch of marks on it. Let's say, what the heck, you just want to make a ruler. I'm thinking about the arm as if the razor blade that would be sitting in here, I'll take like a Dremel or something, or even machine it, and machine a very small little depth channel in here, and then that will sit the razor blade and make another bracket that will go on the outside of this and sandwich a razor blade in. Use a few bolts. Now those bolt holes, I can take other brackets, aluminum or whatever, that I'll be able to mount up on here. So let's say if I want to make a ruler or whatever, I can mount a Sharpie or something like that. Maybe a pen that will work, that's a very fine ballpoint that I'll be able to mark just by going up and down. And then I can take those guides that I'll be making with that slot, guide it in there right underneath the Sharpie or the utensil, and then when this comes out, it'll mark the 0 mark, so you know it'll be 0 at the beginning, and then it'll just be doing all the steps you want at every little distance. Now, I'm also thinking of doing a manual mode, which will be a handheld controller using a vertical arcade 1-axis potentiometer. So I can take the, or even I might even just do buttons to make it simple. I have a few buttons for the different stepping of the speeds, and a few buttons to move it forward and backwards. So let's say if you already have your piece cut, but you need to make marks on it where you're going to glue, you can take that, feed it in, move it out till it's just barely right at the end of the pencil or the Sharpie marker, and then you can start marking it out from there. That'll be 0, and then you can start the program. So then you can input your numbers of where you want your distances of every dot or so on. So I think that'd be a pretty cool deal to have on here to help you out for gluing. And I'm building this simply for excitement and to just do something in the summer, and also for Science Olympiad for boomy levers, towers, bridges, or any other project that I'll be doing, just making stuff at home that has to do with cutting of small balsa wood sticks or basswood even it could probably cut, but multiple lengths and number of the same copies or even short copies, or it's endless of what you can do. But getting back to this motor that took me forever. So this motor originally came out of the post office here in town. It was in something like a stamp machine or something, and what this did is there's a small micro switch on here that's got a flat spot on this axle. I kind of have a Sharpie line so you can kind of see it, but I guess that wasn't a good idea if it's black in the background. But what this does is it can tell where it's at, and this circuit board had a bunch of diodes and capacitors on it, and I was trying to figure out what these pins are coming out here. There's 2 black wires, 2 white wires, 1 yellow wire, and 1 orange wire. So I had all that hooked up. I figured out which one was the motor, which 3 were the switches for common, ground, or common, normally open, and normally closed. And there wasn't a normally closed hooked up, but I manually hooked it up afterwards. And then it went through the diodes and whatnot. And while I was playing around with it, I wasn't using my Arduino Mega. I went and grabbed my Arduino Uno to play with my transistor circuit and figure out what that switch is doing. And my main idea is I can take data from the switch and see if it's either opened or closed, and then I can take that, read it, and then what I'll do is I'll pulse my transistor, or not pulse it, but keep it on for a short period of time, and when it sees that it's closed, it'll move until it sees it's open. So it's in the flat spot, it's open, and when it's in the rounded edges and closed, it's in the closed position. So I'll be able to see that on my Arduino, and I'll be able to make it go around until it gets in the open spot and then shut off the transistor. Well, when I had that hooked up to my Arduino, I made a big mistake. I was running this off of 24 volts, and my wall wart is 2 amps max, and I was playing around with that, and I still had the diodes in there and everything else hooked up. I thought I tested everything of what was coming out when I was going in, but it turned out I only did continuity testing and just to see which wires went where. And when I hooked this up to my Arduino, as soon as this switch closed, even though I had a pull down circuit so I could read the data if it's pulled high or pulled low, well, as soon as the switch closed, it actually redirected my power, shut off the motor, and took all 24 volts and put it right through my Arduino. Which at first I didn't know what was going on. And by that, what I mean is when I had this hooked up, it went on the open, the motor shut off, and I was like, what the heck? Then my computer made this kind of noise. Maybe not. So unplug my mouse. That noise. And then it did that over and over about 3 or 4 times. And I was like, okay, maybe my mouse went to sleep, so I wiggled my mouse and tried to figure out what was going on. That wasn't the issue. It burned my Arduino chip and the USB to serial converter and probably a lot of other things else on that. And at first I didn't know that it blew up the serial to UART chip that usually helps you convert your serial lines into something that the chip is able to read. And I grabbed another Arduino, which wasn't mine, and was my friend's, and I have spare chips, so I replaced the chip, and that was the first one I ever blown. So I replaced the chip, downloaded or uploaded the bootloader to it, and my computer still wasn't recognizing as a device or anything. It just said there's nothing there, it's unable to be reckoned. So I was trying to figure out what was going on, and while I had that plugged in while I was doing the bootloader, I felt that USB to serial converter, and that thing was so hot I actually burnt my tip of my finger. And it was actually getting so hot I could smell it. And while it was even shorting out, I could smell something, but I thought maybe it was just something else. So I could smell the silicon chip burning as if it was frying, because I've fried a lot of circuits on purpose. And I knew it was done for after I smelt it, and I knew the computer didn't recognize it. And then what really scared me is I took my mouse, which is usually on my back port, and then took my programming cable and put it in the front. Well, what I did is I flipped those two around after I got done because I knew my Arduino wasn't any good. So I put those around, and when I plugged it in, it took about 2 minutes for my mouse to actually see, or my computer to actually see that my mouse was plugged in. and because I thought I actually blew my USB port out in my computer. Because I plugged my mouse in, I'm wiggling my mouse, keyboard, nothing happening, turn everything off, syncing them. Pretty soon found it, so I thought, okay, good, so I didn't wreck too many things.